Good morning, everybody. I think it's time to start. Welcome all to this side event of the European Green Week, organized in collaboration with EuroGeoSurvey, Water for All, and Geological Surveys for Europe. My name is Francesco Pizzoccolo, and I'm the project manager of the Geological Surveys for Europe. We are extremely happy that groundwater is gaining the relevance that it has, especially climbing the priority of national and European policymakers. And today, with our speakers and guests, we are going to discuss about exploring the pivotal role of open access data from groundwater quality and quantity assessment. And today, I'll be the moderator of the event. A couple of important information. We are recording the webinar. So please, your microphone know that are muted by default. But for us, it's extremely important that there is a very good interaction between you and the speakers and the panelists. So if you want to interact with them, you can raise your hand during the Q&A session or write the questions in the Q&A part of the MS Team webinar. We have two blocks of speakers this morning. So the first floor will be Julie Hollis, that she's the Secretary General of EuroGeoSurveys, Peter van der Keur from GEUS, the Danish Geological Service, Senior Hydrogeologist, Mariana Gomez from BGR, the German Geological Survey, also hydrogeologist, and last but not least, Klaus Isby, also from GEUS. In the first presentation slot, we will have a presentation from Klaus in a moment, followed up by a few online questions that you'll have to answer. Then we have four presentations by Julie, Klaus, Mariana, and Peter, follow up by, again, online questions, plus real Q&A. Around 10:45, we'll have a short break. And after the break at 11, we'll come back with the speaker from Water for All. So the first speaker will be Ariane Blum, that she's the CEO of Water for All, followed by Sylvain Grellet for BRGM, the French Geological Survey, and Eric Dissing from the Danish Environmental Portal. And they will talk about towards an integrated groundwater and surface water information platform developed by the European Partnership Water for All, water security for the planet. Once again, will be followed up by online question plus some, let's say, live Q&A, and around 12, we plan to end the webinar. Now, we really want to have this webinar that's more interactive as possible. So I really like to invite you to join us on menti.com using the code 71271352, or easier, use the QR code with your smartphone and join us on Menti there, because we like to ask you a few questions to prepare you for the rest of the webinar.
Morning, everybody. Francesco, I can start now.
No, Klaus, not at all.
Okay, sorry. No, okay,
No
sorry. Sorry.
So the first question that we like to ask you is, what are your primary reasons for attending this event? And you can select maximum 2 of those. If you didn't join yet on menti.com, you can do it at any moment using the code that is shown on the center top of the screen, 71271352. Great. The next question is, what do you hope to take away from this event? And you can select as many question answer as you want. So next question, something more about you, and every question that relates to you, you always have the option to say, I prefer not to say, of course. In which stage of your career are you? Now something about our organization. If you know what EGS, GSU, AGDI, and Water for All are. Now we go back to groundwater. So which aspects of groundwater management you are most interested in? And what do you consider the biggest challenges in sustainable groundwater management today? That's it for now. We'll go back to menti.com later. So thank you very much for everybody who joined in the online questionnaire. And now I'm indeed very happy to give the word to you, Klaus.
Many thanks, Francesco. Good morning, all. We'll just share my screen in a second. Yeah. Good morning, everybody. I'm Claus Hinsby from the Geological Survey of Denmark and Greenland, and the Deputy Chair of the Water Resources Expert Group of the EuroGeoSurveys. Before we start introducing the GSEU and the European Geological Data Infrastructure and Water for All, we thought that it would be good to have some general discussion and introduction to how to access groundwater quantitative and chemical status assessments of European groundwater bodies, which all member states have to do and report to the Commission or the European Environment Agency, and who are collating and presenting all these data for public access in general. But I'm sure that some of you will know how to do it and some will not. So I give a very brief introduction to how you can access these data. But before I do it, I would like to say a little bit about groundwater, European groundwater in a global perspective, and about the fortunate increasing awareness globally about the importance of groundwater in general. And then I give a brief introduction to groundwater quantitative and chemical status assessments according to the EU directives and how to access guidance documents also for doing this. And finally, how to access groundwater status assessments reported by the member states via the website of the European Environment Agency and the WISE Freshwater Information System for Europe. And then there's a little surprise at the end, but later more about that. So very fortunate, there was a UN report in 2022. For the first time, the World Water Development Report was focusing on groundwater and making the invisible visible. So this is also illustrating the increasing awareness of the importance of groundwater. And of course, this is, as mentioned here in the circle in the upper right corner, because groundwater accounts for approximately 99% of all liquid freshwater on Earth. And in a short summary from the report, it says that the vast potential of groundwater and the need to manage it sustainably can no longer be overlooked. It is essential that countries commit themselves to developing an adequate and effective framework for groundwater governance. Groundwater data collected with public funds should be freely accessible. And the freely accessible and open access data in general is, of course, we are increasingly important in the management of environment and resources generally. And this has been recognized, fortunately, by the EU, the European Commission, and by establishing the European Environment and the European Environment Information and Observation Network. That is a network of the European Environment Agency and 38 members and cooperating countries, and more than 400 national institutions from these countries. So there's a lot of work going on in Europe, developing and collating information about the environment in general, and also a lot about groundwater and freshwater, fortunately. So, but coming back to the UN World Water Development Report, a few numbers from the report is illustrated here. To the left, you see the total volume of liquid freshwater on the continents globally. And what you can see here is that Europe is here. It has, compared to the other continents, actually quite little groundwater or fresh water available. But if you look to the right here, the per capita freshwater renewal every year is for Europe comparable to the other continents, except for Africa and Asia, which have very little in this, which is not surprising to many of us. So a little corona left over here. And if we talk about the freshwater use by agriculture, household, and industry on the different continents, you see agriculture is actually the largest user of fresh water on all continents, except Europe, where it actually is industry, which is the largest consumer of fresh water. Again, from the report, if you look at groundwater and the UN Sustainable Development Goals, groundwater is only mentioned specifically in goal number 6. But it's actually no less than 53 targets appear to be interlinked with groundwater. I'm sorry for this. So, and if you look at, some of you will have seen the papers on the planetary boundaries during the past 15 years or so. And now the most recent paper from 2023 say that Earth is now beyond 6 of the 9 planetary boundaries, including freshwater change. And if you look at the relation between these and groundwater, it's actually all the transgressed planetary boundaries impact groundwater quantitative and chemical status, or vice versa. So there's a close link between groundwater and these other planetary boundaries which have been transgressed. Now a little bit about groundwater status assessment in the EU. So the European Union has established several requirements for its member states to ensure good status of water bodies under the Water Framework and Groundwater Directives adopted in 2000 and 2006 respectively. And you can have access to these via these links, and you can have access to the Working Group Groundwater documents, Working Group Groundwater within the Common Implementation Strategy for the Water Framework Directive on this link to circa BC. I'm very sorry. Examples of guidance and technical reports that you can get access to here on groundwater status assessments include these two. The one to the link to the left is a link to guidance number 18, which is the guidance on groundwater status and trend assessment, and this is what member states and the authorities here are using quite extensively when doing these for the national reports. And to the right, you see a technical report on groundwater associated aquatic ecosystem, which is something that is often not or often difficult to handle for the member states. It's a tricky part how to do that in this, and hence there was a specific technical report on this developed within the Working Group Groundwater previously. So the EU member states have to conduct groundwater quantitative and chemical status assessments in 3 river-based management plans to ultimately ensure good status in 2027 at the latest, as I'm sure you all know. And we have some challenges getting there, and I'm sure we will not do it. We will not reach that goal or target in many places, but back to that. Here you see different tests that the member states have to conduct within these status assessments, both for chemical status and quantitative status So it's related to both legitimate users and the nature and environment ecosystems. And the 3 river basin management plan and risk assessment, good status at the end, is illustration from the guidance number 18. Here's also to the left an illustration on how to assess the chemical status, and you have to, again, to do it with the environmental criteria, the associated or dependent ecosystems, the usage criteria, the legitimate users, drinking water, industry, agriculture, etc. And you have to select the strictest threshold values or criteria values as a threshold value to protect these users. And again, the figure to the right illustrate this, the link between the groundwater resources and the groundwater dependent terrestrial and associated aquatic ecosystems, that where we also need to derive threshold values to protect these. So this is what all member states are doing and reporting to the EEA, and where they collate the data and exhibit them on their websites and related websites. So here the entrance to these via, for instance, via the European Environment Agency, and you can go to the environmental information systems, and here you can find WISE freshwater information system for Europe, and get access to all these status assessments by the member states. To the left here, you see the entrance to groundwater chemical status, and to the right, groundwater quantitative status. Here you see groundwater quantitative status in different kinds of geological formation or porosity types. And so you see that it's between very few to up to maximum 12% of the groundwater bodies, according to the national or the member states reports, that have poor status. While when we look at the groundwater chemical status, it's up to 26% that has poor status, according to the reports. So these are all maps and illustrations from the WISE freshwater system. And here we zoom into groundwater bodies failing to achieve good chemical status, and looking at 2 examples here in close to where I am now in Denmark. Even it's blue here, you can see that in Jutland, western part of Denmark, 18% of the groundwater bodies are reported to have poor chemical status. While in southern Spain, you see that it's actually 97% of the total which have poor chemical status. So this, of course, varies quite a lot across Europe, and data on how we should interpret these different variations are, of course, important, and we get back to that later in the presentations of the EGDI, the European Geologic Data Infrastructure, and of course also in Water Forward. So this was about the information system available to the official by the EEA and the WISE freshwater information system recently, and some of you will have seen it, but I'm sure others not. There's 7 European media or newspapers that have decided to focus on groundwater and present what are the status assessments or what are the status of European groundwater in general. And this is a great initiative that we can all welcome in order to have better and more widespread dissemination of the situation of groundwater bodies in Europe, which are critical in many places, and which they recognize and help us to disseminate to the wider public in Europe. And so this is their website developed this year in 2024. And besides different newspaper articles, you can have access to a map that they have developed within the project. And here you see the map, an interactive map of the node status of the European groundwater. And you see again here, red is poor status, blue, grayish is good, and there's orange for unknown. If you zoom into Denmark, it's the red areas are more clearly visible, and we can also zoom into the area where I'm located right now, in the Copenhagen area. And you see here we have various challenges, and we have both poor quantitative status and poor chemical status. And these symbols that you see here below the poor chemical quantitative status, CILQS, refers to why or what are the reasons for these status assessments. And you can get information about them. So C here is chemical pollution, other than nutrients. I, alteration in direction of water flow due to saline intrusion. L, groundwater level decrease. Q, decrease in surface water quality associated with chemical and quantitative impact. And S, finally, saline intrusion or contamination. I'm sitting here, so right now. So you see, I'm living in an area with, really challenges both with groundwater quantitative and groundwater chemical status. And that's it for me. Thank you very much.
Wonderful, Klaus. Thanks a lot. Now we are going back to ask a few online questions, and before I do so, Bernadette asked an important thing that I forgot to mention at the beginning of the webinar. We are going to share everything, both presentation and recordings. Please check our website and social media channel, and you'll find everything there. Now I see that quite a few extra people have joined the webinar. So for who was there at the beginning of the event, after each presentation, we are going to ask you a few things ourselves to you instead of you asking things to us. So please join back us at menti.com using the code 71271352, or use again the QR code that is listed on the bottom left. If you already have joined, you just have to go back to the same page and we will start. So I give it a few seconds for everybody to join, and then we can start with the question. Few questions about presentation of Klaus. So first question is, which groundwater pollutants are most threatening for groundwater dependent or associated ecosystem? And you can select at maximum 3. And Peter, Klaus, of course, if you want to jump in and comment of this question and answer, feel free to do it at any time, of course. Thank you for your answer. Next question. Do you consider groundwater quantitative status or chemical status the most critical for drinking water supply?
Yeah, I see many or most say that both are critical, but this, of course, it depends a bit about where you are in Europe. So some places it's only one of them, other places, most we see here is actually both.
Next questions. And what about the same question but for most critical for terrestrial ecosystems? And again, same question, but about aquatic ecosystems.
Here again, it will depend a bit about on what type of aquatic ecosystems, but in general, we see that many consider both important, and otherwise, as a second one, it's chemical status, and that could, for instance, be nutrient loadings, as we've seen before, to lakes, coastal waters, etc.
Thank you, Klaus. So that's it again. Now I'm very happy to give the word to Julie Hollis from the Secretary General of EuroGeoSurvey, and we are starting the second session about how to get access to groundwater data. The word is yours, Julie.
Great. Thank you very much, Francesco, and good morning, everyone. My name is Julie Hollis. I'm the Secretary General of EuroGeoSurveys. So I'm just going to give a big picture overview of who are we, EuroGeoSurveys, and the project, the flagship project that we're involved in, the Geological Service for Europe project. So EuroGeoSurveys is a collaborative network of European Geological Survey organisations, with the mission of enabling the sustainable and responsible use of the Earth's subsurface environment and resources, of which, of course, groundwater is a key resource. Our flagship project is the Geological Service for Europe project, which is a 5-year co-funded European co-funded project, coordination and support action, which draws together the baseline subsurface data and knowledge to manage Europe's natural resources, and with the aim of reaching net zero. And the ultimate aim of our project is to deliver a sustainable geological service for Europe, which should be a geoscience data, information and knowledge-based advisory service to support achieving this sustainable future for Europe. So why do we need a geological service for Europe? Well, headlines like these are very common. I'm sure you all see them almost every day. Concerns about resource management, and here I'm talking about a whole range of natural resources, the critical minerals, the critical raw materials that we need to deliver green technologies, complete overhaul of our energy systems, the energy itself, the transition to renewable energies, and groundwater, of course, which is under pressure. So the Geological Service for Europe project involves largely national and regional geological survey organisations, but also some other research partners. We are 48 partners from 35 countries. And as I said, the overall goal is to deliver a geological service for Europe in order to achieve sustainable management of the subsurface. How do we do this? Well, we start, first of all, from the data. So working across different countries, working with the geological surveys who are often the mandated authorities to collect, archive, deliver the data of the subsurface. And we're working to make this data fair, findable, accessible, interoperable, and reusable, delivered, harmonized at European scale, and ultimately take that all the way through to being able to provide decision support information relevant to policy. And where are we relevant to policy? In many different areas. Here are some of them. And particularly in regard to groundwater, as Klaus has already mentioned, the key framework that we're working with is the Water Framework Directive and also the Groundwater Directive and all of the policy around that. This is a very a simple overview of what the project looks like. So we have these 5 different geoscientific thematic areas that we're working with across Europe, of which one is groundwater resources, which some of the experts from the project, including Klaus, will discuss in more detail after I speak. And then we have central to the project is the European Geological Data Infrastructure, where all of the data is drawn into this central platform where we can deliver harmonized data for at continental scale. Why are we working on groundwater? Well, I think that's already fairly obvious, and Klaus has already shown this image from a publication from last year showing that we are already outside the safe operating space for 6 out of 9 planetary boundaries, and now freshwater change is one of those. So the project, the Geological Service for Europe project, is what we're currently working on with so many partners, but this is not a starting point. We have been working collaboratively across the Geological Surveys of Europe for many years. In fact, EuroGeoSurveys is an association which is more than 50 years old. And since 2010, we have had this focus on the European development of the European Geological Data Infrastructure as a common data platform, a common strategy of trying to deliver harmonized data at European scale to inform policy. EGDI was launched in 2016 during the GeoEra project, which preceded the GSEU project, and now here we are in GSEU, and the European Geological Data Infrastructure is now stepping up to the next level of further development and deployment. But with that, I will end there and pass over to Klaus, who will say more about that. Thank you.
Thank you, Julie. Oh. something strange happened. Do you see my screen?
Yes, you have to put it in a full screen.
Okay,
Klaus,
thank you, Francisco. I got some strange messages on my
now it's
screen.
perfect. Now it's perfect.
Very good. Thank you, Julie, for this nice introduction. I hope I can complete this presentation without coughing again. I continue with how to access groundwater and geoscience data in the European Geological Data Infrastructure, or EGDI, to support groundwater quantity and quality risk and status assessments. The data that we provide is not directly involved in the status assessments, but to interpret actually the pollution, distribution, etc. in the groundwater. But it is really important to understand the physical and chemical characteristics of the subsurface. So that these data that we collate are very important in evaluating the situation across Europe, both in relation to groundwater quantity and quality. And here is the link to EGDI, the European Geological Data Infrastructure. So a bit more on EGDI. It's an initiative, as also introduced by Julie, originally initiated around 2011 to save results from many European projects that previously, when one project was over, maybe a website continued for some years, and then it was not possible to get access to results anymore. So EGDI was developed also to ensure that we keep the data in for the future. And then there was a scope project in 2012 to 14 to establish an EGDI and to operate it. The first version of EGDI was in 2016, developed by the EGS members, and especially the Spatial Information Expert Group. So EGS has 10 different expert groups, and besides the water resources expert group that I represent, we have, for instance, also the Spatial Information Expert Group. And the initial funding by developing it was from the EuroGeoSurveys. And then we got the Euro program and Euronet on applied geoscience. And it had 14 different geoscientific projects, and it was between 2018 and 21. And then I think it was continued a bit into 22 because of Corona. And then we continue this within the work on developing EGDI within the GSEU project that is now running, and you will hear a bit more about following this presentation. So it is now recognized as a fundamental element of the future geological surveys for Europe. And if you enter the EGDI platform, you will see this entry with all the icons to the left here, and you can click on the map viewer, and you will be able to provide or develop maps, as you see here to the right, combining many different subsurface data in these map views. So it has more than 5,000 metadata records, more than 800 WMS, WFS services, more than 1,000 layers, and more than 5,000 thesaurus terms to search for in EGDI. It supports a lot of different projects. I'm sure not everyone is on this, but it gives you an idea of all the different projects, and you also see the 4 GeoEra projects here: the TACTIC groundwater project, HOVER GeoEra groundwater project, the Resource GeoEra groundwater project, and the Vogera GeoEra groundwater project. And EGDI also connects to many other digital information platforms in Europe, and collaborate with them to make sure that we have easy access to all the important data that we are collating on the environment, etc. To ensure that we have fair access to data, or this findable, accessible, interoperable, and reusable data for everybody in Europe. So a bit more about the 4 EU groundwater projects that I just mentioned and their contributions to EGDI. On top, you see the HOVER project, which was primarily on groundwater quality. To the right, you see the resource project, which was primarily on groundwater quantity. At the bottom, the tactic project, which was primarily on groundwater and climate change. And then finally, to the left, the Morgera project, which was primarily on groundwater vulnerability to deep energy-related activities. So closely linked to other of the important activities of the EuroGeoSurveys. And here again, at the bottom, you see that it's primarily related to UN SDG 6, but it has actually also is of importance to many of the other SDGs, as already mentioned in the previous presentation. So to show and give you an idea of the different data that we have collated and presented, exhibited on EGDI. I will show you examples both of groundwater quantity and groundwater quality. So here's if you go into the map viewer of EGDI, you will be presented with this map, or the map you want, not the map actually, but here you will get a drop down menu to the left, where you see all the different kinds of data that you are able to find on EGDI. So basic geology, marine geology, mineral resources, earth observation, geohazards, geoenergy, geochemistry, groundwater, geophysics, boreholes, and geographical topics. And of course, we are interested in groundwater primarily. If you click on groundwater, you will see the data here and maps organized in groundwater quantity, quality, drinking water and health, transboundary aquifers, climate change, competing uses, ecosystems and biodiversity, and finally hydrogeology and geological features. So if we look at examples on groundwater quantity and climate change, I will show here a pan-European map of average potential groundwater recharge between 81 and 2020 that was developed in the tactic project, and near real-time water table measurements and future protection based on these. And then finally, European groundwater resources maps present the data on volume, depth, and types, etc. So the pan-European potential groundwater recharge map was developed in the GeoEuro project between many of the partners, and it uses data from national monitoring and modeling in these 7 different countries you see here, from Spain in the south to Finland in the northeast. And then they used machine learning and satellite data to extend this and to cover all of Europe. And you can access the data and download the data for your own research and work if you want to compare your local study with these. And there's a link to the paper from this work at the bottom here. We also initiated a European map viewer for near real-time measurements of groundwater levels. Here's an example of measurements in a Swedish borehole. And also the Swedish Geological Surveys developed website which shows the situation, also projected within how will the water table develop within the next 30 days or 60 days. And this is something that we are working on developing in the follow-up, the GSEU project, which is has a lot of attention to these water table measurements and how we can use this for assessing groundwater quantitative status in Europe. And then a bit more about groundwater quantity. Here's European groundwater resources maps. To the left, you will see groundwater storage in the groundwater bodies in the different parts of the participating countries. I should say that not all member states were involved of all activities. Therefore, you see that some countries did not provide data for this for these maps. But of course, we hope in the future to receive such data so we can have a full map of Europe. To the right, you see the total depth of the different groundwater bodies, and what you can notice here is that, for instance, in Finland, all of their groundwater bodies is within the upper 50 meters of the surface, below the surface, and of course these are then, Finland has a lot of nature, so that's not a problem for groundwater, but in agriculture and urban areas are very vulnerable to pollution from the surface. In France, for instance, around Paris, you have the Paris Basin where groundwater bodies are actually reach close to depth of more than 800 meters. So there's quite a lot of variation within Europe on this. Few examples of groundwater quality. We worked on human health and ecosystem health perspectives. Organic contaminants and inorganic contaminants, and of course nitrate, which is an important and often the contaminant that most frequently cause poor status of the European groundwater bodies. So here you see the member states involved in work on emerging contaminants. And these people, some of these are also involved in working group groundwater and initiative there, where they are working on a specific watch list for the emerging contaminants, where they are assessing how important the different contaminants are, and one of these, of course, is PFAS, which is an increasing problem also in groundwater bodies. If we talk about it's not only the contamination that is a problem for groundwater quality, also inorganic. It could be contaminants, but it could also be natural eugenic elements that cause problems. Here you see fluoride and arsenic. And many of you will know that arsenic is by some considered actually cause of the largest mass poisoning in history in Asia, and high arsenic concentration is a problem in many groundwater bodies across the world, and cause serious health issue like cancer, etc. And to assess the standards, quality standards, and whether they have contamination, but then you need to understand the natural background levels of these, and this is what we have been working quite a lot on also in the GeoEuro project, the groundwater projects, and continue to work on in the GSEU. So finally, a few words also about the power of geoscience map combinations. So understanding the distribution of the aquifers is, as I mentioned previously, closely related to the physical and chemical characteristics of the subsurface. And this is just an example of about how many different kinds of geoscience data you can compile in the same map. It's actually 6 different maps combined in the same, and you have geology, marine geology, terrestrial geology combined with fracture systems online and in the sea. You have seismic activity, which is very pronounced. You see here on Iceland and in Turkey. And you have in the yellow circles geothermal water. So all these are data compiled from the different topics, subtopics that you can select on EGDI. Just as an example of the importance of these. Many for instance, arsenic can be in some areas related to the fracture systems, and the same goes for the geothermal waters. This is actually illustrated in this map, where you see arsenic and fluoride combined with the fracture maps of Europe, and so the data on fluoride and arsenic was collated in the groundwater project and the fractures in the geoenergy project. So all these data are relevant to each other. And up in the right corner here, you see examples of how geothermal waters could be linked to some of the fracture systems in the Pannonian Basin and areas close by. Of course, it's also important in relation to contamination risk, for instance, for mining activities, which we also have mapped. And if we combine the mining activities with the groundwater bodies, you can see in what areas could we expect that these will actually have a risk in relation to groundwater contamination, etc. As I also mentioned, sound understanding of physical and chemical characteristics of the subsurface is imperative to support the interpretation and assessment of contaminant distribution and migration in European groundwater. Here are a few examples. To the left, you see nitrate travel times in the unsaturated zone in Denmark, the Netherlands, UK, and France, and also here in Corsica, I think. And what you see is in Denmark, the Netherlands, there are very short travel times, very shallow unsaturated zones. So nitrate travels fast through the unsaturated zone to the groundwater bodies. While in the UK and France, you will see that in some areas there are quite long. And this, of course, is of importance when interpreting how the different measures in the countries to remediate the nitrate problems is affecting the situation. In the middle, you see a map of oxic and anoxic groundwater bodies, and nitrate doesn't appear in anoxic groundwater. So it's, of course, also important to use that information for interpreting nitrate in the subsurface. And then to the right, you see a general assessment of the vulnerability of groundwater bodies in the different involved countries in the geo area. And that was it. I mean, thank you very much for your attention.
Thank you, Klaus. And before we go to Peter, Peter, you can already prepare your screen. Would be great if everybody will give a look of our data platform, GDI. So there are really a lot of very interesting data. and we are constantly working on improving the platform. So if you have any tips, suggestion of what's missing or what can be better, please feel free to reach out to us. Now I'm very happy to give the word to Peter van der Keur. He's one of our group leader at the Geological Service for Europe of the Groundwater Resources Group. Peter, you're there?
Yes, I'm here. Thank you, Francesco.
Be great you can turn on your camera. Great. Nice to see you. The word
nice
is yours. So
too.
next to speaker is Peter and Mariana.
Thank you. Thank you, Francesco, and good morning, everybody. I'm Peter van der Keur. I'm from the Geological Survey of Denmark and Greenland, as my colleague Klaus. And I will get on this session, which is with the long title, as you can see here on the first screen, and you already heard Julie and Klaus. So on the general context and on previous projects of relevance for the project I will present together with my colleague Mariana from the German Geological Survey. So I will tell about the GSEU, which is the Geological Service for Europe, as you already have heard about, and get some more details on how the issues, as explained, presented and explained by especially Klaus, how they are approached in this project. And we do that in a way that I will just present shortly the workflow, and then Mariana will tell about the groundwater quantity aspects, and I will tell about the groundwater quality aspects, and then we will wrap up in the end.
Peter,
So,
Peter,
before you continue, can you put full screen, please?
Should be full screen now. Ah, okay. Sorry. Yes.
Yeah, now it's perfect. Thank you.
Okay. Thank you. Sorry. Yeah. So the Geological Service for Europe project, it's about assessing groundwater quantity and quality, and we do this in a way as is depicted here in this slide. On the left-hand side, you can see how data is collected from partner geological surveys across Europe, and this data may be real time or non-real time, and depending on the purpose. So this data, which is basically a time series data, and since this is on the groundwater quantity, this is the groundwater level data is a kind of a proxy for this. And so these time series are collected, and they are being standardized and harmonized, as you can see in the second block from left to right. And this data is then processed in time series analysis and used in the end for forecasting, which is the last block on the right hand. And we also use methodologies, other methodologies for assessing the vulnerability of groundwater aquifers, especially towards drought. And so this is the way we approach the groundwater quantity in the project. And I will now give the word to Mariana to tell about some more details. Mariana, the floor is yours.
Thank you, Peter. So as part of the groundwater quantity, we focus mainly our efforts into the harmonized and collected and harmonized the groundwater levels across all the partners from the project. So most of them are geological services or smaller institutions, in order to come all the data together in what we will call, or we are calling, the European Groundwater Monitoring Database. This will consist of a harmonized but also standardized according to the OGC standards, so the Open Geospatial Consortium standards. And according to this, there are different sub-activities that we are performing based on this data, which one of them one of them. It's the groundwater trend and drought analysis. So this is mainly to see what are the main trends across Europe, what are the main trends in the time series. Then another sub-activity, it's the groundwater resilience. So that's just to detect which aquifers are more like what is the resilience or what is the vulnerability of the aquifers across Europe. So this is more in the spatial distribution of the aquifers. And so as the last activity also, it corresponds to the short and long-term forecast. So this is more into the groundwater level modeling into the near and the long future. The idea is to not only display the European Groundwater Monitoring Database in the EuroGeoSurveys platform, but also to display some of these other future analysis. So that means the trend, the groundwater resilience, and the modeling of each station. So we can display some sort of map, as you can see the scheme of if like to detect where is like high water levels or we have low water levels. Next, please. So as I mentioned, as also Peter mentioned before, there is like big efforts into the collection of this data. And because of this, as some of you might know, there are really big differences depending on the country on how the groundwater network consists, how it's distributed, and how is actually also each station, how does it work, and how automatic the data can be collected. That means we need to be open to any kind of like system of the geological service and get a way to collect also like the data that is upgradable and the data that is more like manually collected. And that means we will have two versions. So that means we have an static data set, but also our aims is to look to some near real-time series. And of course, this comes with a lot of collaboration with our IT group and our IT support in order to collect this data. So the ones that are automatically, we can collect it via some API or some batch script or like some a way that we can collect it more like a long term. But also we need to allow some more manually upgradable data set. And the aim of this is then to collect it in a main data center that will keep the EuroGeoSurveys platform on long term updated with groundwater level data. Next, please. So as a general picture, there are many techniques that can be used in order to analyze, pre-process, and modeling groundwater data. And our aim is to use some machine learning models or some data-driven approaches, since we are dealing with a pan-European scale. And this allows us to access to some explainable variables more easily. And that means so that we will get into data pre-processing also some of these methodologies, but also making some clustering, understanding which dynamics can be related to each other, and try and test different approaches in the modeling. So that's for me. So I will go back to Peter. Thank you.
Yes, thank you, Marianne, for this very clear presentation. I will then continue. As I said, there are two parts in this in the GSEU groundwater project, the groundwater part project. It's on the water quantity and quality, and I will continue with the quality part, which, as you can see from here, builds on existing data. So Klaus already mentioned and showed a lot of data being collected in the GeoEra project, and we, to the extent possible, will build and reuse these data, which also told by Klaus are stored in the EuroGeoSurveys information data platform, and we will use then this data and in combination with newly acquired data to determine and assess and visualize the water quality patterns. And these patterns, the groundwater quality patterns, they to a high extent depend on what is the geological, the hydrochemical, and hydrological conditions of the subsurface. And this then will be part of the EGDI, so that the EGDI data will be extended with this newly acquired data, as you can see on the right side. So the groundwater quality needs. Sorry. Okay, sorry. It has two aspects. So we look at the groundwater quality patterns, so the spatial patterns and trends, and they are, as I said, dependent on the geological, hydrochemical, and hydrological properties of the subsurface. That is one part, and the other part we focus on is the mobility and the persistence of various contaminants in relations to drivers and pressures and uses on the conditions of climate change. So this data is collected from the geological survey partners across Europe and used to analyze this. So the methodologies we use for this are in some way similar to what we use under the groundwater quantity part. So also here we use machine learning techniques, which you can see on the left-hand side. So the geostatistics, the machine learning parts. We also construct a matrix which lists how human activity is related to groundwater pollutants. So the link between the human activities, anthropogenic activities, and emission of harmful pollutants into the groundwater. And all these data are then visualized via the EGDI platform, which you can see on the right-hand side top, and also using various tools which will be implemented in the EGDI as planned. So you can see here in the middle part how online groundwater chemical data can be visualized and analyzed by clicking on wells, and also nitrate or trend assessments will be done. And as an example, I can show you the nitrate trends on the right hand side bottom. So this is basically what we do in the groundwater quality part of the project. And so the main takeaways from both the quantity and the quality part are that we collect data on both groundwater quantity and quality, and we do this in collaboration with all the GSEU geological survey partners. Data is then harmonized, and it's used for analysis, for the trend analysis, and also in the end being used for the forecasting activities, as Marianne presented, and all these data we collect are stored in the geological monitoring database, and then finally in the EGDI. We also use data-driven modeling, both for the groundwater quantity part and the groundwater quality parts, and we use this for analyzing and for visualizing trends and evolution of groundwater contaminants. And so this is what I wanted to say. Back to you, Francesco.
Thank you very much, Peter, Marianne, and Julie. We are going back now to few online questions, and then we can start a live Q&A. while the audience will answer a few questions via Menti. Maybe Peter and Mariana, you can read the question that is in the chat, and we're going to start with your answer as soon as we are back here online. So then I will ask everybody to go back on menti.com or to use the QR code on the bottom left of the screen, because we have a few questions about the presentation that just finished. This question is, what is, oh, sorry.
Francesco, you're not sharing.
I see. Apologies for that. Back in a second. Thank you, Aurete, for letting us know, and good morning. Great, I think now we are there. So again, please use the code on top left or join us with the QR code. So for question is, and in these few questions there is a correct answer or not. What is EuroGeoSurvey? Should have hidden the answer for these few questions, just show at the end. And this indeed was the correct question. What is the vision of EuroGeoSurvey? Also, here was the correct answer. This is a bit more difficult. Was part of Julie's presentation. How many partners there are in the GSEU project? So here the correct answer indeed there was 48, slight majority, because the partners of the GSEU is much broader than just the 27 member states, and then there are also several regional geological surveys. So there are 48 partners for 35 countries in the GSEU project. Then a curiosity from us. So after the talk of Klaus, if you will give a look about what's on the GDI platform. Very nice to see some honest maybe, but very happy to see that there are no no's so far. So now go back at the topic of the webinar. What is, in your opinion, the main cause of depleted groundwater reservoirs? Peter, Klaus, Mariana, feel free to join already commenting the answers to these questions. Next question, you can select at maximum 3. how will you use forecasting groundwater levels in your catchment?
Yeah, and I think for this question, it's also important to remember that it is both for the short and the medium and the long term forecasting. So from months until decades. And that of course will have an impact on what kind of what answer you are selecting.
Thank you very much for your questions. Next one. What type of visualization of groundwater contamination is most useful to you? It looks like we have a clear winner. Both.
Yeah, here you can add that you actually in the status assessments had to assess both. So it's yeah, would be of course the expected answer.
And I think that's it for now. Now I would like to ask Julie, Klaus, Mariana, and Peter to turn off their camera and their microphone. And I would like to start with the first question for yours. So, hi, Peter and Mariana. Do you think that on-site measurement of groundwater flow, velocity, and direction can improve understanding and insights? Because, of course, Joris thinks so. It'll be the key to define the critical location where to extend monitoring network with groundwater flow sensor.
Mm-hmm.
So, what do you like to comment on that, Peter and Mariana?
Maybe I can start. Well, I for sure, I also think it is also an important information and really useful. Although I think is really dependent on each network capacities. Because like even for the groundwater level data collection is already sometimes not more than that collected. So I would say like if it's really challenging to collect additional information from that, but of course like it will be a really useful. Peter can.
Yeah, I agree, but in the project, this is not part of the standard measurements. But I agree with Maria; it would be very useful.
Thank you.
And if I may add, I think that especially in studies on pollutant migration, contaminant plumes, this information will be very relevant. If you are talking about larger regional pan-European data, it's probably less, at least for the time being. But if you look at some specific pollution plume studies, etc., it will be really helpful.
Thank you, Klaus. Yesterday, I got via LinkedIn a couple of questions, so I'd like to ask. I think this question will be mostly for Julie, I believe, but the rest, please feel free to join anytime. So what is the relevance of the work that we are doing on groundwater for European policy and legislation?
Okay, well, at present, as I think both Klaus and I referred to the overarching policy framework as the Water Framework Directive and the Groundwater Directive. But I would also say that there is an increasing EU level focus on water resilience. And this is likely to feature in the next framework program for research and innovation funding in Europe. It is, of course, a focus for EU Green Week as well. So there is certainly an increased, and I should also mention that Ursula von der Leyen in her first speech for the new Commission made reference to water resilience as well. So there is a clear, stronger focus on water resilience, and groundwater clearly plays a very important role there. I don't know if anyone else wants to add anything to that.
Yes, I think I would also like to add that in you mentioned green transition. Will green transition, will Green Deal, there's an increasing pressure on the subsurface and an increasing need for the subsurface in developing an efficient green transition. And this, of course, give additional pressure to groundwater, freshwater in general, but of course also groundwater and other competing uses of the subsurface. This really requires an extended and increased understanding of the subsurface of Europe.
Thank you. Next questions will be mostly for Peter, I believe. What are the coming milestones in terms of availability of groundwater data?
The milestones, well, it's Mariana. She presented is the development of the European groundwater monitoring database. So that will be the first milestone, big milestone, to get the data which we collect from groundwater partners, so the geological survey partners, into the system. And this is for this we have developed a data model to how to do this and how to make optimal use of the stored data. And then the next will be the analyzed data. So the groundwater level data will be analyzed, and from this in the end we will derive the forecasted data. And so the data storage itself in the European groundwater monitoring database, and then the processing of the data. And then following the forecasting activities from these data.
Thank you, Peter. And so if we combine a bit all the presentation that we saw so far. So Julie was talking about EGS. Peter, Klaus, and Mariana showed the work that GSEU and EGS are doing on groundwater resources. So how this work is relating to the future sustainable geological service for Europe?
I can perhaps start there, and I think this goes back to what Klaus was saying, is that really with the increasing effects of climate change, the pressure to deliver Europe's net zero goals, there needs to be a holistic approach to management and use of the subsurface, of groundwater resources, of raw materials, of energy resources, of protection and management of natural environment, and so on. So in order to do that, we need to have this common service which treats the subsurface as a single system for understanding the Earth processes that affect all of these different areas and affect all of these different industrial sectors in Europe. So this is really where groundwater ties in to, it's a crucial component of such a geological service, which should have a common basis in pan-European data and should address all of these different thematic areas in parallel with strong communication between different scientists from different areas of expertise.
Julie? I think the next question, maybe Klaus, is for you. From
maybe I can also, if I'm allowed to add to Julie's, I fully agree with her and can mention that there is a year ago there was a report from the Stockholm International Water Institute more or less stating that there is basically no green transition that doesn't involve freshwater in one way or another. And this will, of course, as I mentioned in my initial presentation, groundwater being 99% of the available freshwater resources, very important. Groundwater is very important in that aspect, but it is also very important that we integrate groundwater and surface waters. So, and I'm sure we will learn more about that in the next session with Water for All. Data and efficient integration of groundwater and surface water data is important for sustainable management of our freshwater resources and protection of water supply and nature.
Thank you, Klaus. And what do you guys like to comment? The comment from Charis, but very interesting when the factor of climate change appear from the questions, believed to have little effect on groundwater.
Sorry, I need to hear that again. Can you please repeat?
So it's very interesting. You can also see it in the Q&A, Klaus. But it's very interesting that the factor of climate change appear from the questions. I believe to have little effect on groundwater.
If I understand. I don't. Mariana, will you?
Yeah. So it's definitely climate change have definitely a big effect on the. I mean, a certain amount of effect also on the groundwater level depletion in certain areas, also on the high, mainly we'll say on the extreme events. So you like not in all the stations, but in many of the observations, you can see some clear trends. And if you compare it to the climate predictions or climate modeling, then you can see like some correlations between both and this link. And I think, Klaus, maybe you can expand this, like how is the link about this climate change and the groundwater, because yeah, it's clear so far.
Yeah, maybe Maria, before Klaus, I think it's also important to mention that we mentioned the near real-time data. So it is very important, of course, for the forecasting activities that the data delivered by the surveys will be updated. There will be a continuous flow of data, and so this the signal of the climate change, which is expected to be more strong in the near future, can be detected and can be used for improving groundwater management.
Thank you, Peter.
Thank you.
Agree. And if I mean, there's of course there is a large variation across Europe. So the situation is different in Spain and is in Denmark, as we so Spain is a dry region and they will experience water table decline, no doubt about that. While in Denmark it's the opposite is the case. We expect increasing groundwater levels, and we have already relatively high groundwater levels and shallow unsaturated zones, as I showed in one of my slides. And this actually will, for us, we will probably experience more issues with high groundwater levels and groundwater flooding with climate change. Then, so the situation varies quite a lot across Europe and of course globally.
Thank you. I think we can close with the last comment. Peter, I don't know if you can read it. Will you happen to have a document ready to the workflow to use groundwater time series data posted on the website?
Yes, I can say that we are currently working on a report on especially on specifically this topic, and it will be ready by beginning of next year. And so I will keep this in mind. So it will be ready. It will be a public document which with all the details of the groundwater time series data.
Thank you very much, Peter. And again, a reminder for everybody. So everything that we do in the Geological Service for Europe is going to be publicly available. So all our products and deliverables are free to download on our website. There are no further questions. Then I would really love to thank Julie, Klaus, Peter, and Mariana for their contribution. So now we are going to enter at a 15 minutes break, and then we will continue with the colleague of the Water for All. So thanks again. Welcome back, everybody. Great to see that we still have 70 people online. And with great pleasure, I'd like to give the word to Ariane Blum, the CEO of Water for All. Please, Ariane, the stage is yours.
Thank you very much, Francesco. Do I share my presentation directly? Yes?
Yes, please. Yeah.
Okay, so can you see it?
Perfect.
Okay, great. Just a second. Yeah, so good morning, everybody, and thank you once again for the invitation. I'm very pleased to attend this meeting this morning. My name is Ariane Blum, and I am a scientific officer at the French National Research Agency, and I'm the coordinator of the Water for All partnership. I'm particularly glad to be with you today because I'm a hydrogeologist by background, and I have worked many years for BRGM, for the French Geological Survey, and I'm happy to meet old friends during this meeting, even if it's virtually, unfortunately.
Yeah. Sorry, Ariane, we see your one note in front of the presentation.
Which is not interesting.
Yeah. No, now it's perfect.
Is it?
Yes.
Is it okay now?
Yeah, perfect.
Okay, great. Thank you. So the purpose of my presentation will be to give you an overview of what the Water for All partnership is. And then I will leave the floor to my colleagues, Henrik and Sylvain, who will really focus on what is foreseen within Water for All regarding data issues. But I understood well at the beginning of the webinar that not most of you don't know about Water for All, so it's a good opportunity to give you some information. Okay, so before talking about Water for All, I just would like to explain why this partnership has been designed and set up, because you all know about the water challenge, and I won't go too much into details into these figures, but just to highlight that we have decades of research projects dealing with water, with surface water and groundwaters. And unfortunately, at the European level or at the local level, unfortunately, more than 20 years after the publication of the Water Framework Directive, we still have 60% of our surface water bodies that are in poor status, and it's 30% for groundwater. And of course, Klaus has gave us some detailed figures before. So it means that it's not sufficient, and that we need to give a fresh boost to the management of water, including research projects. So this is the idea behind for the European Commission. And Water for All is a co-funded partnerships under the Horizon Europe program. And just for your information, under the Horizon Europe program, the Commission has decided to really focus the funds on 49 priorities, and water is one of these priorities. The second novelty under this, with these partnerships under Horizon Europe is to gather together funding agencies to gather our funds and to increase and to make sure that we have enough funds to support research actions, but also to build a consortium of funding agency, research organization, local authorities, and representatives from the economic sector. And the idea behind is to really make sure that the result of research projects we are going to fund will be transferred to end users, including policymakers and the economic sectors. So Water for All started in June 2022, and it's a consortium of 90 partners, as I said, mainly research organizations, but not only. We represent 33 countries from European countries, but not only, and this is also something very important. We have to face a global challenge, and so we have collaborations with non-EU countries like Brazil, South Africa, Turkey, and we really aim in the future to strengthen collaborations with new countries. Water for All will last 10 years with a significant budget of more than 400 million euros. Water for All activities are in line with what we call a strategic and research innovation agenda. There has been a work during 2 years before the launch of Water for All to really set up what are the topics that are our priorities, and they represent the research gaps and the policy needs. So we have 7 core themes that you have here on the slides. I won't give you too much details, but it deals with water for circular economy, water for ecosystem and biodiversity, sustainable water management, water and health, water infrastructure, and 2 of them are cross-sectorial issues, international cooperation and governance. This document is available on our website. And what I would like to say is that it's a living document, because all along the implementation of Water for All, we may find new research gaps or new policy needs. And this is why we are going to revise this document by the end of 2025. And there is a public consultation running on until the middle of September. So I really, the link is active and it's on our website. I really invite you to look at this consultation. If you feel that some topics are missing, don't hesitate to contribute, because it's very important for the future. If we focus on groundwater and the place of groundwater in this strategic agenda, I would like to say that there is a dedicated sub-theme dedicated to groundwater management, as you can see. This is really an important topic. And of course, groundwater are considered in every other topics when dealing about river basin management plan, for instance, when dealing about circular economy, of course, when dealing about ecosystems and biodiversity, groundwater are very important and are included there. Okay, so to make it concrete, what are we doing within Water for All? Let's say that we have 2 kinds of activities. The first one is to fund joint transnational calls, research projects gathering at a minimum of 3 countries. So this is something very classical that you may know from the Horizon 2020 program. And we plan to implement 6 joint transnational calls. The first one was on the management of water resources in hydroclimatic extreme events. The second one is on aquatic ecosystem services, and we will be able to announce the results of this call at the end of September this year. The third one will be on water for circular economy, and I will give you some more information just after. And the fourth one on water and health that will be published in 2025. And we didn't decide yet the last 2 topics. And the novelty in such a partnership in Horizon Europe is that we don't only have these joint transnational calls, and that we also have a kind of internal work program and what we call additional activities. And I will give you some example of what are these additional activities just after. Just coming back on the calls, if you are interested in knowing more about the funded projects for the first call, please go to our website, and there is a booklet presenting the 27 funded projects through this call. And for your information, 7 of these projects are dealing with groundwaters, which is not that bad. The second call, and yes, I would like to give some information about the third call. A pre-announcement was published in July regarding the third call. So it's about water and circular economy. And you have here the 4 topics of this call. And it's mainly about water and circular economy in the context of industry and urban water circularity. And a particular emphasis also on economic and social issues. The official publication will be done in 2 or 3 weeks. So stay tuned if you're interested in applying to this call. So just for your information, with these calls, we fund 3 years projects with a minimum of 3 eligible partners from the participating countries and a maximum of 7 partners. And we really encourage the cooperation between public and private institutions. Okay, so a few words about our additional activities, the novelty. So these are activities carried out by the partners of the Water for All. And I'm happy also to say that we are able to welcome in the future new partners, but I will go through this at the end of the presentation. The first range of activities are to really make the connections with end users and especially policymakers and the economic sectors. So we have 4 tasks that are summarized here. The first one is on science policy governance interface, and to really see how Water for All can support the implementation of the Water Framework Directive, the Drinking Water Directive, and the Urban Wastewater Treatment Directive. So it's completely in line with the first presentation of Klaus, and we really hope that our results will contribute to update these results and works. The second one is dedicated to the support to SMEs, the development of a European incubator. I won't go too much into details today on this. The third one deals with the capacity development, especially the support to PhD at the European level, actions regarding the youth and young people, and training for non-professional. And the fourth one, which is the most important today, is the development of an open science and open data strategy and database that Henrik and Sylvain will give you some more details about this just after. I would like to quickly also mention that a part of our activity is dedicated to the development of a network of water-oriented living labs. You may know that living labs are a kind of ecosystems to support the development of innovation, and to, before developing an innovation or research projects, to first ask the end users, especially the local authorities, citizens, and the representatives from the economic sectors about their needs, and then to really create a real synergy between innovation and end users. So there is a network of more than 100 living labs across Europe. And there is an atlas which is available on our website also. And we really hope to support connections between different sites across Europe, and to really have benefits of one innovation in one part of Europe for another part of Europe. And the last type of additional activities I would like to mention is that we have international activities, and we aim at creating cooperations with non-EU countries, like I told you, but also making sure that we are able to valorize our results, the innovations funded by Water for All in international conference, because one important thing is to really have an impact, to make sure that Water for All results will have an impact on the EU Green Deal, but also on the SDGs. And this is why we are very active in contributing to international conference like the UN Water Conference in New York in 2023, or during the World Water Forum Bali this year, And for instance, we were responsible for organizing a session dealing with upscaling of water information systems. So this is also a way to build new collaborations in terms of science and to promote what we will be able to develop in the coming years. And that's all for the general presentation of Water for All. I just would like also to remind as a conclusion that because this is the EU Green Week and the topic is the EU water resilience, to remind that there is a key role of research and innovation when implementing a European water resilience, and that cooperation between scientists, citizens, policymakers is really important to speed up and to be more resilient. Of course, you know this already, but I think it's very important to remind this. And the Water for All contribution to the EU water resilience will be about deliver of knowledge and solutions through the funded projects, but also solutions delivered by the SMEs we are going to support, by research centers participating to Water for All, by the PhDs engaged in Water for All. And it's also a question of awareness to policymakers, to citizens through the walls. And of course, data sharing will be very important and in line for the water resilience in Europe. So this is an important topic. And I leave the floor to Henrik to explain what we are going to do in details on this topic.
Thank you very much, Ariane, for the presentation. And indeed, the next speaker is Erik Dissing from the Danish Environmental Portal.
Henrik, you are muted.
Erik, when you're ready, please turn on your camera, share your screen, and you can start.
Actually, we may have lost him. I don't see him in our list.
Okay, I'm sending him a message to check that.
Yeah. But if Erik is not available,
I'm next to Henrik.
Okay.
Am I going through?
Yes, we hear you.
So Henrik and I and myself were in the same office in Copenhagen, so we will try and speak through my microphone. Can you confirm you hear Henrik correctly? Go ahead, Henrik.
Yeah, I hope I will. You hear me now?
Yes.
Can someone confirm in the chat?
Yeah, everything is okay, Sylvain. You can go ahead.
Go ahead. He said go ahead.
Okay. What I will do is I will give you an introduction to that we are working on a white paper on best practice in water data management. And why are we doing that? That is basically because in order to support our constituency, the researchers and then the innovators in delivering relevant results, it's quite straightforward that that they can find and access relevant data, and that these data are interoperable and reusable. However, that's not the case. So we're trying to look into what could be best practices, what are problems and barriers, what will the details of such a best practice system be, and how shall we move on. Before getting into the details, I'll give you a very quick background of the organization I come from myself, the Danish Environmental Portal. And one of the reasons for doing that is that we are a digital hub. In Denmark, we are distributing data from across biosphere terrain elements. So it's all sorts of water, soil biodiversity, chemicals, even rats, and it goes out to 2,000 organizations. And that means that for that to be useful, no slides.
No, I'm asking. Go ahead. I guess.
No, we
Okay.
don't see anything, guys.
Okay, it seems that Henrik's computer crashed partly with Teams, so I will share my screen with Henrik's slides.
Yeah.
Sorry for the intro. So I need to share that screen and that slide. Which one did you want to share?
Sure.
You're on the front page?
Yeah.
Okay, you tell me next slide.
Okay, just go ahead. Now, what you can see 2 slides down. What you can see with this structure is we got quite a lot of subject groups, so it means we are in very close interaction with our users, and that also means we got a quite good grasp of the value creation, which and the preconditions for that out there among the users. Please.
So that we will manage. Yep.
Okay. What we are also hereby doing is we're both working with the soft infrastructure, data sharing agreements, but also the hard infrastructure and a combination of that. What we see, if you go to the next one, is that data is used in ways we have never imagined among these 2,000 organizations. And that really requires that tells if data are findable, accessible, and interoperable, quite a lot of creative people are able to develop solutions which actually shapes the digitally based environmental management we are all talking about. So a prerequisite for that is the interoperability across these biosphere terrain elements. Please, next one. And that also is that we're working according to a vision where both public authorities and private actors ideally should share, use, and reusable, observable, and measurable data in a standardized, harmonized, and true and fair way. And that is the fly into this. Let's take the next one. An example of how we have been doing is we have been harmonizing the data in side of hydrometrical data, starting with flood level, river levels and flow in rivers, but moved on to groundwater and using now exactly the same data in system for groundwater levels and as well for marine levels. And we're looking into overflow levels as the next one. And what that implies is that in climate change adaptation context, we can now use data across these sources or for flood warning or other type of uses because of that we as an intermediary have harmonized these data on behalf of the users. And that allows for multiple use in multiple contexts of the same raw data. Please, next one. What we also see is what we will be close to call a paradigm shift for managing environmental data. We see if we go years, maybe even decades back, that the research community was the driver in data collection for research purposes. You would also could in that one have said that utilities was among, but what really happened in the big picture next was driven by EU systems and requirements on reporting. A couple of requirements came up which put monitoring really at the core of driving a collection of environmental data. But what we see now is decision support systems based on advanced digital tools looking into being the key solutions for addressing the comprehensive environmental problems we are seeing, which requires ability to look across biosphere elements, across water and biodiversity, water and chemicals, water and energy, water and use of area, etc. And the foundation for doing that in a smooth and cost-efficient manner is to reduce blockers for interoperability, which basically requires a same approach to data management, thus the white paper. Next. Just an example of what we're going to do in Denmark, a system coming up where we're trying to integrate area, space, physical space needs across 6 big drivers: groundwater protection, one of them biodiversity, another one renewable energy plans, and of course space for agriculture. But they all require more space than we actually have in Denmark. And we need a digital tool to optimize how we can do the decision making. Again, data management foundation is that how data are harmonized across the various fields, because otherwise we lock in a lot of unnecessary, unproductive cost for what we do, what some people call, I don't like the words, but data mining and data washing. Move on, please. Another tool we have made is we have in order to speed up time of processes for environmental impact assessments, we have made a tool where we can upload environmental impact assessment reports, use AI, scroll through, and you can type in whatever you want, which topic you want to examine, and you get a quick overview of where data are, what the main results are, etc. And that has shortened the time spent on environmental impact assessments. Benefit in Denmark is at the scale of 100 million euro, and it has costed us 5 million euros to develop the system. Next. In Water for All, we are copying now that solution, again for scientific documents, reports, data management plans, articles, what do we have? And the idea is again to be upload any such scientific documents first of all from our constituency, but ideally also for others. And again, you can easily search through these often PDF-based reports, which you will never find anywhere else. And hereby also, that goes for the findable and accessible part. That doesn't change the interoperability. Next. I think some of the new developments we see, I'll just mention one. In order to deal with planetary boundaries, we need to have a data management foundation, having that data follows the problems we're looking into. Next. But there are a lot of difficulties in data sharing. One is data models, IT architecture. Top management don't really follow this. They don't basically know anything like that. So we don't have the right leadership level decisions about how to deal with this, how to example giving, have that key standards are followed. So instead, we just develop our own data models, coming what we find relevant. We don't have this integrated approach, and that constitutes a blocker. One element, straightforward, we should use the same EU code list for observable properties, example giving chemical substances. By chance, here in Denmark, we have a tool where you can, for 1,500 chemicals now, you can go in and you can see the code list number in 5 different classification systems. That means interoperability are easily acquired using such a tool. Now that should be made EU mandatory, and we would immediately for sharing of data with chemical substances be able to make that much more straightforward. Next. Easy thing is, across all sectors, given a lot of generalization, IT experts spend 80% of their time for unproductive activities, only 20% for creating value due to these interoperability problems. So any ideas of having a data-driven digital solutions management system bumps into this problem because we don't have the interoperability. Next. So this white paper tries to approach it, try to argue we need to understand and describe data in the same way. We need to build leadership level attention to see this as strategically important, and based on the observation that the current practices are too focused on unproductive actions. The structure is, and I'll rush through it, you will have a chance in a few weeks to access it and read and comment. But that is, first of all, what's the potential for value creation? As you remember the example with the environmental impact assessment case, value in Denmark, 100 million euros. Cost for the system, 5 million euro. Now that's value creation. That's how we should discuss matters. What are barriers and problems? And they are very different. They are often not technical. They are often something generated by people who wants to build something of their own, who wants to be unique and special, etc. So people are often the blocker for creating this. And that's why we need the leadership attention at different levels. And then we start envisioning what such an ecosystem is and some recommendations. Next. On the potentials, it is reducing cost and time spent by environmental authorities. I mentioned EEA case, but there are a lot of other ones, example giving at municipalities and governments. It's allowing for better integration of water, for example, data on water flows, levels of rivers, cloudbursts, stormwater, etc. All of that constituting climate change adaptation tools. It's for researchers and innovators to find and access, and it should have said, relevant data. It doesn't make sense if we want researchers to contribute that they can't access national monitoring data. And that's the case in many countries. It doesn't make sense. It doesn't make sense that hydrometric data crossing regions or country boundaries are not in the same format. Why? Next. Operational cost is something often hidden, but operating data management systems comes with cost, and we should reduce those ones. Otherwise, we'll never get the smart systems. Smoother transfer of data within national levels, but also between national levels and inside EU systems. And here there are room for improvement. Again, coming to the better digital decision support is key to all of that. And again, allowing for better communication, also for people who are not technical, but even for civil society to follow, etc. Next. There are a lot of barriers and problems of different types. You can get a glimpse of just reading the bold characters. I don't have time to go through it, so you just get this glimpse. Next. More problems and barriers. There are loads of them. There are lots of us to do. We move on. And here a lot of things IT architecture should support. And now we're getting closer to what could be content of best practice. That's, of course, not just another day in the office. And the next presentation, you will hear Sylvain giving a glimpse of what does it take to try to build let's call it a coalition of the willing who actually wants to make an ideal system. What are their experiences? Next. That's also why we have the fair principles, but just to tease it a little bit, we want to basically add a U, because we need to understand data in the same manner. We need to describe and understand them in the same manner. That's the starting point. Next. So a small illustration of what is the starting point for building logical data models. Again, we need to look at the feature, the overall problems we're looking into. We need to describe the monitoring stations or the sites in the same way. If we don't have the same approach to the geographical dimension, where are we? We can't compare at all. And then we go into the sensor technologies or whatever technologies we use, and then we look in a same classified systems, the results of our monitoring. Next. And that is again how to use and observe them. I'm sorry, I don't have time to do it. It will be there for reading, but it is super interesting to start debating, and this what you can call outside in perspective of what could constitute a European water data ecosystem. What will it take for us? And that goes again across sectors. It goes across borders and boundaries, and it goes across vested interests and certain perspectives of being unique and special. Next. Yeah, that's just an example what it would look like. Again, time don't allow. Sorry, next. And a lot of recommendations, and they of course take their starting point from all of the all of the vision and the barriers and problems envisioned. And some of the things we have been doing in Water for All is we have been trying to test by concrete data sharing of hydrometric data, building APIs for this purpose, and then observing where do we actually come across various problems we have to manage. But all of that, Sylvain will tell you more about. I think that should be end of my presentation. Crash course on, yeah, I'll just move on. And yeah, that's it for now. Sorry for a lot of things at heart, a lot of things to present, but 10 minutes doesn't bring us so far. Over to you, Sylvain.
Okay. Let me move to my presentation. So I'm going to complement what Henrik just presented, and by trying to give more in-depth insight from the, let's say, the technical part around sharing groundwater data and also surface water data, identifying barriers and problems, and also what's the proposed way ahead and the solutions we've identified. So data exchange content, this one context, this one will be quick because it overlaps slightly with what Henrik presented. But the long story short is that, I mean, we can take every system and we know in various countries, most of the time, we will find specific implementation websites. Okay, that's nice, but not really shared international practice being deployed. And I can give example also on how it is in France. We have a nice system, but how is it internally working for other non-French speakers, people outside the system? How can they just find data in it? Same goes for surface water. We could do the same drill for the European Environmental Agency reportings data sets. That could also run in outside Europe if we take a close look at how it goes in Australia, in the US. I'm not saying there is no standard there. There are pieces of standards being deployed, but we cannot have the full puzzle picture nicely on the table. So just quick focus on three main barriers from the IT perspective, but as you could have seen from Henrik's presentation, there are way more barriers like on human side, organization side, etc. So if we just look just only from the IT perspective, many countries just do use different semantics to structure data. Just on the left side, that's a copy paste from the Water Quality X, WQX spec in the US and reused in some other country. On the right side, that the spec from the French information system on groundwater quality. Apart from the fact that one is in French, was in English, that even the conceptual baseline is not the same one. Also, countries do use different semantics to populate data. Henrik already scratched that topic as well. Even if we do share data models, the same data models, as long as we don't have shared code lists here, that's just an example. This one on surface water, 2 stations next to the other on the Rhine, one in the French water information system, one in the Land Baden-Württemberg, Germany system. Okay, with an expert, you just take a seat for 10 minutes and you will manage somehow with brains, human brains, to just identify and speak about the same topic. But that should be a bit more streamlined. And the last aspect I was willing to emphasize on is, apart from semantics, I like the technicalities. For those of you that are not IT people, you often hear words like web services, APIs, and stuff like that. And again, most of the time, not always, but most of the time, you will find different APIs, techniques, systems deployed in countries to share the same types of data, which obviously hinders streamlined data exchange. So how can we move from that? So recap of the barriers on the top. As I said, there are often ad hoc local solutions. I should have had a legacy system in place. So the proposal we've got here is to use internationally agreed upon fair water data practices. From where? Do we start from a blank page? No, of course, no. There are already dynamics lying around in systems organizations like the Open Geospatial Consortium, the World Wide Web Consortium, Research Data Alliance, and Inspire. And you just need a little more coordination and support so that it actually moves in the same direction. Because most of the time you will find groups of people acting under those different levels. So there is a quest for those people to try and end up with a coherent solution. So most of the time people do refer like to Open Geospatial Consortium to do WebGIS. Okay, that's nice. That was a real breakthrough almost 20 years ago. But people do tend to overlook that what happens under the OGC is highly driven through domain working groups. I listed some of them. And for those who don't know, just don't imagine how much like aviation, land surveyors, meteo systems across the world are revolving around the standards. And it turned out that in OGC, there is an hydro domain working group. So I will emphasize on that one in the next slide. So just a quick recap, what happens in OGC is coordinated with the International Standard Organization. It's also coordinated with the World Wide Web Organization, W3C, that does the standard for the web data, for data exchange on the web as well. There are joint efforts with Research Data Alliance, and obviously you may have heard that several times, but it's those standards are highly recommended and implemented in the Inspire Directive context, but also in the research infrastructures and project, and I just quoted EOSC as an example. Just a quick focus, because I'm not so sure many people know about this one, and I guess in such a webconf it's important mentioning it. The Hydro Domain Working Group, it started around 2007, 2008. It's a joint group with OGC and the World Meteorological Organization for the hydro part. Even WMO is also involved in the MET groups of OGC. This group has been running, as you can see on the right side, a long history of what we call interoperability experiment to test and craft what end up in standards under the WaterML2 line, and you have example on the bottom left corner. And those standards are implemented, obviously, in the WMO system, but in many other national, continental, international organizations, in open source tools as well, and proprietary ones. And it's being regularly updated. And you can, for those who don't see yellow, it's here. It's the effort that is currently running since 2 years. We have actually a test on the water quality data exchange that will feed this line of agreed upon practices. So quick focus on what's going on there. The long story short is it started from a workshop we had jointly organized with WMO, UNEP, World Health Organization, and UNESCO around water quality data exchange. This was under the World Water Quality Data Alliance exercise. It was covering both surface and groundwater. And then after that workshop, we decided to launch such an exercise called Water Quality Interoperability Experiment, WQIE for short. And after almost 2 years, more than 77 meetings and several impromptu, what do we have right now? Thanks. We have. I need to just adjust sound on the side. Yeah, I have echo here. We have a best practice on how to exchange water quality and a bit of quantity based on the International Standard for Observation and Measurement. That was exactly what was mentioned by Eric before in the best practice document, in the white paper, sorry. We have a tooling specification that comes along with it, because on a spec without tools, it's just like a nice poster on your wall. The tooling spec with water quality extension and also reference implementation. We have various endpoints that are deploying providers and including clients, and we have a steadily growing uptake. We will summarize. We started just that phase right now as I speak. Write down an engineering report that will just lead to evolution in standards. So I will give, because the presentation will be shared, there's a link for the full demo gave in June this year, the reference point on GitHub. What do we do there? We do agree on a shared international approach with regard to semantics and technical practices to share water quality and also quantity data, surface and ground analysis. Who is involved in that? We have many waterfall partners applying this to their data sets. Also, we applied that to the one European Environmental Agency dataset. We have also water quality IE members outside Europe members. And also some of the EU GSEU project partners are also playing that game. How do we do that? By deploying the solution we've agreed, and also by deploying testing with clients. So long story short as well, I will just mainly share images, but it's just a tip of the iceberg. Obviously, most of the time has not been spent on crafting a nice graphical user interface. It's been spent on defining how the system will expose the data and the data structure and the semantics. So the first example is left side, raw in situ groundwater quantity and quality data in France. The right side is in the US. If we move to surface water quality, that's the same. That's French and Germany this time, and putting here it's calcium data next to the other across the borders. It's for some stations. And this is an example. I had to pick some of them, sorry. On the Y state of the environment water quality Y6 reporting, that's a Finnish station, and you get aluminium data. If it's feasible just to kind of, in a way, plug and play a generic viewer on top of all those data sources, because there was no hack and not everything is put in one same system, it's because we've reached a certain level of interoperability. Going away from the web, obviously data transits through the web, but we can also ingest those same data through standard GIS desktop tools like QGIS. We funded through Waterfall the evolution of the tool so that it meets the standard. We ingested the same data sources in source tools like R. And to prove also the connectivity, we also connected some of those endpoints. This time, the fourth compartment, surface water quantity, here it's in France again, connected to the World Meteorological Organization, the WHOS, WMO Hydrological Observing System. And it's not me who wrote those slides, and that's basically WHOS people. And it just took them a couple hours in a well-motivated afternoon just to connect to the endpoints. So from that, how do we shape an integrated groundwater and surface water information platform? There are other components we've tried and tested and prototyped in Waterfall. One is obviously vocabularies, and Rick mentioned the list that is of chemical substances that exist in Denmark. We have the equivalent system in France, and we have also systems like PubChem or the research infrastructure. We use the best practice from the FAIR communities to share vocab to link them all together to traverse all across systems, and you get the link. This is the entry nitrate concentration, and you see how it is encoded in various countries. Same example, like for DDT, for example, and I could go on, and we have decided obviously to continue working on that in the second phase of Waterfall. There are other components I don't have time to describe, but one is working a lot on a fair water data specification to support the development of practices and the standardization work to share specification and guide providers, users to deploying them. Next steps we have identified is to stabilize what we found in the interoperability experiment and also provide support to newcomers. We are investing a lot as well on open source tooling for the community, basically to lower the entry ticket for both data provision and also data ingestion, data reuse. So we are also planning to stabilize what we've been working on for 2 years in the standards. And also we have a joint effort ongoing with the World Meteorological Organization that invests a lot of time and money into generic tools for the Met organization all across the world that cannot afford all that research and development we're doing. Client side, we have to continue the momentum, and also we are targeting more mature and simple clients so that we add the interoperability to water specialists. So that's not their job, so that's just so that their life is easier. And we're working on adding virtual research environment components. Obviously, we have metadata catalog that will expand as the list of data sets grows. We have linked data resolver, or otherwise we couldn't do linked data example I described before. And what I label that ugly name water data verifier is basically what Henrik presented with the solution to share documents and help organizations that don't have the capacity and knowledge to share data almost according to the fair water data practices and climb that fair data ladder. Yes, there is a visible part of the iceberg, the graphical user interface. I grabbed several screenshots of that presentation, but obviously that's just really the tip of the iceberg. The core, the essence is in the data management practice as emphasized by Henrik, the standards and the toolings and training as well. So we will work on that one to make it easier for access. As you can see, I just decided to give you a quick screenshot with data coming from various parts of the world to show that there is that momentum going on. I do expect to see much more data in Europe thanks to Waterfall. but also in other places of the world like South America and also in African countries as well. There are initiatives stemming more from the WMO side, still on the same standards. There is a movement there. There are other use cases we will be working on. I just put an underline and italic to those we focused, because we have to start somewhere, the obvious one, and we obviously make those one more mature and also move to the others as they come from the community. So conclusion around what we're doing from the IT side is really working in that triangle I tried to shape quickly in the plane this morning, is setting up international fair water data practices, fulfilling community needs, which also means that the community needs a focal point and express its needs. Then when we're clear on the standards, supporting open source solutions in implementing those practices to provide organization directly with tools to reuse, that's also a matter of generating value to some extent, and deploy those tools within the community. And actually what we try to set up, sorry, so an ugly copy paste last minute, but what we want to do is really trigger a virtuous cycle, because when we deploy the tool and the standard in the communities and at the data providers or data consumer level, then we can feed back either on the tool and or the standards to say, hey, we've missed that point, there is a glitch, we need to enrich. And that's the beginning of a virtuous cycle. And all the connection we have all across Europe and the globe on those topics I just described make me pretty confident on the dynamics. And yeah, that was it for me. Feel free to shoot questions or email. Thank you.
Thank you very much, Sylvain. We do have a couple of questions for the three of you, but before I would like to ask the audience to join us back on Menti, because there are a few questions for you also about this free presentation that we just had. So please use the Menti code that we are using so far, 7127135 or use the QR code on the bottom left. So the first question, and this is like a free typing answer. How will it benefit your work if data of other organizations were fair, findable, accessible, interoperable, and reusable? And feel free to give us a practical example.
So, sorry, how do we give the practical example, Francesco?
No, just right. I mean, like I like the first one that said that like to use them to benchmark numerical models. I mean, we all understand it would be great if the data would be fair, but I mean, why and for what you will use those data?
But we cannot add them now to the Mentimeter, so we do it.
Whatever you like, Klaus. So you
okay.
can say it out loud or write it down.
Okay. I think this would be very important for of course, in my world, for integrated groundwater, surface water modeling, and also including climate, ecosystems, and being more and more integrated, advanced socio-economic issues, etc. So it's very important to have these fair access to all kinds of data.
Thank you, Klaus. So next questions is, have you got easy access to national monitoring result reg groundwater? Thank you for your answer. And the last questions from Menti, or maybe two. Are your own data automatically shared with a national water data hub? I guess that the answer clearly underlined the problem. So for the moment, I'd like to thank everybody contributing on menti.com, but please stay with us a few extra minutes. Then I'd like to ask, Ariane is also, the camera is on, great. We do have a couple of questions for the three of you. I think people wants to know a little bit more about Water for All. So first question is, so it's clear that Water for All focus on fresh water, but do you do anything about marine waters as well?
Yeah, I can say that indeed we focus really on freshwaters, and that there is another partnership named Sustainable Blue Economy dealing with marine waters, and they also include a part dedicated to data sharing and data dissemination, and this is something we will have to look at in the future to make connections between. I could also quote another partnership named Biodiversa Plus. You may have heard about it. And I hope also in the future that we can connect our database and what Sylvain and Henrik have shown to this data, in particular when dealing about Biodiversa Plus. They provide and they support natural-based solutions, so there are clear connections with the groundwater community. I don't know, Sylvain and Henrik, if you want to add something on this.
Thank you. Another question is about Water for All and policy especially. So how does Water for All support the implementation of EU water-related directives?
So I went very quickly in my presentation through this topic, but there is a task dedicated to the support of the directive, and what we call a policy support group. It's led by the International Office of Water in France and VMM in Belgium. And it's early, but there will be a forum at the end of this year to gather policymakers involved in the implementation of these directives and the Water for All community to really strengthen the collaboration. So I really encourage you to follow Water for All, and I didn't mention that we have a newsletter and a website, and we have an account on LinkedIn and X. So if you want some information about this forum, it will be delivered by the end of this year, and there will be other meetings next year. So.
Great, Thank you, Ariane. Sylvain, you want to add?
Yeah, just to complement what Ariane said, next to the policy making support, there is also at the beginning of a fair or data exchange support that just starts right now. And if you remember, in one of my slides, we prototype how could data exchange on top of some EEA, European Environmental data set, how it could look like according to the international practices. So there is also the data part that comes along with that support.
Yeah. Klaus, please jump in, and you can turn on your camera. When Julie, Peter, Mariana, you can turn on your camera as well, because when I have a question for everybody to close the event in a moment.
Yeah, it's more common like a question. It's actually it's very important, and I'm happy with this waterfall initiative. It's very important to be able to have fair access to groundwater quantity and quality, surface water quantity and quality, and able to combine these in integrated hydrological groundwater surface water models that we really need to assess how climate change is impacting our systems. And this also actually is relevant in relation to the previous question about how marine waters are covered, because this is something that is we all very often forget, that there's a link between groundwater quantity and quality and surface water and the ecological status of the ecosystems. And there's a link between, for instance, groundwater quality and the ecological status of coastal waters, transitional and coastal waters, even though it doesn't have to be directly groundwater discharge to these systems, but groundwater discharge to rivers, and that provides for instance, the nutrients to the coastal waters and have being the cause of pure status of these.
Thank you, Klaus. Good. I think we are reached to the end. I do have a quick final round for everybody. So, meaning the audience, we have a very broad range of attendees. So from ESPER, we have people from government. We're only some colleagues that were just curious to know more about groundwater. What can everybody do in their daily life to protect the groundwater, and what can everybody do to make sure that the groundwater is always very high on the table of policymaker priorities? Who wants to start? It's an easy question. Klaus, you're the only one unmuted.
Yeah, but I don't know if it's an easy question. We have tried that for a long time now, and Ariane and I was involved in the old days when before the final adoption of the groundwater directive, and it's something that we sometimes have seen in the European programs that it has not even been mentioned, groundwater. So it's a continuous work on trying to get groundwater higher on the agenda, and we are doing what we can, doing our best to make that happen and make groundwater visible, etc. All these different kind of slogans that we had tried, and which also ended up with a UN World Water Development Report on groundwater a few years ago. So I think we're getting, and this new initiative by some European media is very, very helpful also in getting groundwater higher on the agenda.
Thank you, Klaus.
I would also say that the capacity development is, of course, very important. I mean, what you said, well, what can everybody do, including the experts, but also everybody, and that would be to keep yourself updated on developments. For instance, by visiting relevant websites, as have been shown a couple of times also. But it would also be nice if water management, groundwater management, could be included at schools, for instance, in the curriculum. That's maybe somewhat further apart, further away, but that would be really good to make people aware of this problem, not only among experts and people working on groundwater and water management in general, but starting from the very beginning.
Thank you, Peter. Sylvain.
I will add my 2 cents more on my part, the kind of related to what I presented. I'm working a lot with organizations outside Europe around water data exchange, and I do feel there is really a nice alignment of planets with what happens outside Europe and also what we've got with those two projects all together. So I guess it would be great when those of you are touching data generation or project that generate data structures, API and stuff like that, not to reinvent the wheel and really work together as we already initiated with those two projects and partners outside Europe into defining and stabilizing those practices to share water data. Because otherwise we will end up in a really sad situation where there is a domain of citizen interest in the topic, but we will have added by not listening too many hurdles to easily share that information, then we will lose some more time. So stop reinventing the wheel and let's work together.
Thank you, Sylvain. Mariana.
And maybe just shortly, I think it is really important and relevant that groundwater is being shown through different kind of areas. That means like with the GSEU project is through the geological, as a from the geological point of view, as a georesource, but also like from other kind of areas, as like just the water sources alone. And so I think these different angles give it a different overview of what is the situation.
I see thank you very much, Mariana. I see a question of Mary. Can we be equipped with certificates? I'm not sure I follow your question. So if you can explain us a bit, otherwise we'll have to move on. Ariane, you would like to say something extra about the importance of water and what everybody can do?
That's a big question. Everybody can do, or my everyday life? I think that once again we need to speak about water in our family, to our colleagues, and to the media. Also, I think it's really important to talk to political people and to the press and to media, because this is where we can create a real awareness and impact to engage people into water issues. Because we have a lot of knowledge. What is very surprising for me is that we have a lot of knowledge already. Of course, we still have gaps of knowledge and things to do. But as long as this knowledge is just in our hands, as experts, it has no impact. So I think it's really, really important, and this is something that we aim to do to provide policy briefs for the European Commissions, for other directorates than just the GRTD, and for politicians at the national level or at the local level. I think this is really, really something important, and it goes with the awareness about groundwaters.
Thank you very much, Eliane. Well, I think that was a great way to close the event. So again, this was the EuroGeoSurvey, GSEU, and Water for All EU Green Week event towards a water resilient Europe. Thanks again to everybody who's attended. So was a long webinar, 3 hours, but was a real pleasure. We really hope that we entertain you, give you some extra information. Soon the presentation recording will be available on our website and social media account. Please stay tuned for account of EuroGeoSurvey and Water for All, and we hope to see you again in the upcoming event.